Welcome to our second organic chemistry naming video. We are going to go over some simple side groups with naming. So first we need to know what those side groups are. So let's say you have a long carbon chain. You've got this sort of a thing, carbons, carbons everywhere. And then all of a sudden, somewhere down the line, it breaks off into something else. Those have, there are different things that it could break off into. For instance, it could break into a methyl group, which is one carbon, CH3, which is called a methyl group. Or you could have an ethyl group. How many carbons would an ethyl group have? It would have two. Or you could have a propyl group with 3 carbons. Sorry if you hear my cat. He's just demanding cuddles and he's not getting them. So anyway, this goes on. It continues on. So you have butyl, pentyl, and so on, but that's rarer. So you'll see methyl and ethyl a whole lot, and propyl every once in a while. You could also have a chlorine attached, and these are called chloro groups. You could have a bromo side group, and you can have iodo. So these here, they end, the methyl, ethyl, propyl ones, they end with il, YL, because they're not part of the main chain. They're not part of the main chain. So they get this special little ending on their name, and it's something that's just attached to the side. And I'll give you some examples, but the last thing I want to tell you is, before that, is let's say there are 2 methyl groups attached. So on my example, what if I had 2 methyl groups attached where those question marks are? If I have 2 of them, I'll say something like dimethyl. Di means 2 groups. What word or prefix do we use for 3 groups? We'd use tri. And then what do you think we'd use for 4? We would use tetra. So let's do a quick example. Let's say I had this. And there are hydrogens on here. And then here we have let's put bromine over here. Okay. So the first step is to count the longest carbon chain. So there's more than one way you could count this. You could do this 1, carbon 2, 3rd carbon, 4th carbon. Or, let me pick a different color. You could say maybe that this is the first carbon down here. 1, 2, 3, 4. Or, let me get another color. You could say that this is the first carbon. 2, 3, 4. Or, you get the idea, you could go like this. 1, 2, 3, 4. So there's lots of different ways that you can number these, and you have to pick one and stick with it. You can't use all of them. So what you need to do is make sure that you pick the numbering system that gives you the lowest possible numbers for your side groups. So for instance, I've got a bromo here. That's an easy one to pick out. I'm probably going to have one of these other ones like methyl, ethyl, or propyl, but let's start with bromo. If I number with the orange system, bromo is going to be on the 2nd carbon. If I number with the purple system, it's also on the 2nd carbon. If I number with the yellow system, it's on the 3rd carbon, and the green system is also the 3rd carbon. So that's actually not as good. So I want to get rid of those. Let me erase them. Let's see, can I do this quickly? Ooh, my goodness, it's so sensitive. I don't know if you're able to see my erasers. If you are, witness my shame. Okay, well, while I'm having issues, why don't you try to figure out if there is an ethyl, methyl, propyl or whatever group on here. Okay, so we have, well, let's say we pick the orange system just for whatever. Let's look at the orange system. If I use the orange system, I've got my 4-carbon chain here, and then I have this extra little group down here that's not part of my main chain. So that only has 1 carbon, so this is a methyl group. Up here we are, well, I already decided, I hope you were okay with that. I chose this to be a bromo group. That's what it is. It's got bromine on there, so it's bromo. Okay, so using the orange system, I have this as a methyl group. If I use the purple system, then this carbon over here would have been the methyl group, and that, so here, let's go, let me back up. This methyl group right here, if I count using the orange system, is on carbon number 2, just like the bromo. If I count using the purple system, this carbon will also be on carbon number 2. So it really doesn't matter which system you use. So just for the sake of things, I'm going to circle these. I'm going to use this numbering system. You can ignore the purples. So now we have to decide, all right, what's the name of the main chain? The main chain has 4 carbons on it. So what's the prefix that we use for 4 carbon chains? We use, I need more space than that, bute. Does this have any double or triple bonds? No? What kind of ending do I use then? I use ane. So now before it, we're going to label these groups. And we'll do this in order of number. Well, they're both on the 2nd carbon. So what I'm going to do is say 2, and you can go in alphabetical order, which is nice, 2 bromo. And then there's a methyl group on the 2nd carbon as well. So 2 methyl, 2 bromo, 2 methyl. And that's it. That's the name for this guy, 2-bromo, 2-methyl butane. So you need to count the carbons, figure out what the longest possible chain is, and then label all of the different groups that are attached. So let's go ahead and practice that now. You might want to reference your notes for these. Here are some that I created before the video. So let's do the first one together. Unless you're feeling great about this, then by all means, go on. So first I want to find the longest possible carbon chain. So let's see, I have, if I count from over here, I have 1, 2, 3, 4, 5. Or if I count from down here, I have 1, 2, 3, 4, 5. So it's 5 either way. So my core chain is going to be what if it has 5 carbons? 5 carbons is pent. And then does it have any double or triple bonds? Nope. Pent, ane. Okay, so now I need to pick a place to number from. Let's see, it doesn't, well, okay, I'll show you 2 different examples. Just 2 though, this time. If I count like this, I've got this group down here on the 2nd carbon. However, if I count like this, now this group is on the 4th carbon. So which one do I want to pick? The one where the group's on the 4th carbon or the 2nd carbon? We want to pick the group where it's on the lowest possible number. So we're going to pick the numbering system that puts it on the 2nd carbon. You just pick whatever numbering system gives you the lowest possible numbers. So it's going to be on the 2nd carbon, so we'll put a 2 here. And then what group is this? What is it called? It's 1 carbon, so it is a methyl group. So 2-methylpentane. That's what this is. All right. I think that you should do one more with me before moving on, unless you want to give it a shot, then why not? So let's do this one. Let's try to find the longest possible chain. I could count from over here and do 1, 2, 3, 4, 5, 6. Or if I count from down here, I could do like 1, 2, 3. Oh, that's not very long. How about 1, 2, 3, 4, 5, 6? Still 6. Looks like 6 is the longest I'm going to get. So 6-carbon chain is with all single bonds is called what? It would be called hexane. Okay, now let's say that I'm counting the carbons along the straight chain. I think that makes life easier. So we're using just the straight chain right across. Do I want my first carbon to be on the left or on the right? I'd want my first carbon to be on the right, because if I do that, all of these things that are hanging off the edges are assigned a lower value number, which is our goal. So now I'm going to go in order here. We'll start with the number 2. See how I have 2 things attached to the number 2? You're going to do this, 2, 2. They're the same. Well, here, let me back up a little bit. There are 2 things attached to this number 2, and they're both the same thing. So since they're the same thing, that's why I get to do 2, 2 instead of like 2-methyl, 2-propyl. So 2, 2 because they're the same, and since there are 2 of them, I'll say di. And then what's the name of a single carbon group? Methyl. All right, so these 2 are named. Now I have something on the 3rd carbon. And what is on the 3rd carbon? It's a bromo group. So this guy is 2, 2 dimethyl 3-bromohexane. Don't you feel fancy naming that? You should. Okay, this is your opportunity to practice without me now, so you should pause and try the next 2, then see how you did. All right, I hope you paused. Welcome back if you did. So now we need to do our numbering again. Looking at this, I'm seeing a 1, 2, 3, 4, 5 carbon chain. That's starting here, 1, 2, 3, 4, 5, versus doing 1, 2, 3, 4, 5, 6. Okay, I can get a 6-carbon chain out of this. So a 6-carbon chain would be hexane. I don't see any double or triple bonds, so ane. And then I have to figure out how to number it. Well, if I number it as 1, 2, 3, the bromo gets the 3, 4, 5, 6. Then I'll have this thing attached to the 4. So I've got a 3, 4 thing going on here. If I use a different numbering system, like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. In that case, then this chunk off to the side is on the 3rd carbon, while the bromo is on the 4th. Ooh, tricky. Well, okay. Why don't we just do this alphabetically? Bromo would come before what this group is. It's a 2-carbon chain either way. What's a 2-carbon side group called? It's called ethyl. So I want the one that comes alphabetically first to have the lower number. So I want the one that starts with B because E comes after B. I want that one to have the lower number. So I'm going to back up and I'm going to use my orange numbering system. Some of you who paused and tried this out, you might have numbered it the other way around. That's not a terrible mistake to make. It's fine. Don't worry about it, but try and do this if you can. So we've got 3 bromo, and then we've got this ethyl group on the 4th carbon, so 4, ethyl. 3-bromo, 4-ethyl hexane. All right, and now let's try the last one. If you haven't tried it yet, go ahead and pause and try it. And okay, so now I'm going to do it. Well, obviously this is a 3-carbon chain, so this is going to be but wait a second, is it propane? No, it is propene. Okay, so we've got propene. Now we need to number it, and we've got this iodo group on the edge here. I want it to have the lowest number possible, so 1, 2, 3. So that's going to be on the first one, so I can actually just say iodo. I don't need to say 1. Iodo propene. And I'm going to look into something really fast. Actually, I'm going to have you move on, but I might back up in a minute here to talk about this double bond and where it's located. So just hold that thought on the double bond. What you should do right now is try drawing these guys. So you're going to try to draw 2-ethyl propane, 2,3-dimethylhexane, 2-chloro-3-methylheptene, and 2,2,3-trichlorobutene. Butine. Oh boy. All right, so go ahead and try that out. You can pause and try it. I unfortunately cannot pause, so I'm stuck right now. All right, I'll add an annotation in later about that double bond. So you should have paused and tried these out. 2-ethyl propane. Okay, prop. Let's see. Meth, eth, prop. 3 carbons. So 1, 2, 3. This is ane, so they're all single bonds. Okay, and then I want on the second carbon, so well, doesn't matter which way I number this because 1, 2, 3, 1, 2, 3. Either way, the middle carbon is it. I want an ethyl group, so I'll do this. Oh, interesting. So this is actually going to run into a problem. We're going to run into a problem. So if I were to do that, okay, assume these are all hydrogens on all of those little dashes. You can do that sometimes. Is that name possible to make? Not really. If we have an ethyl group hanging off the middle of a propane, we actually end up with something that has 1, 2, 3, 4 carbons. So this is kind of a little bit of a trick here. 2-ethyl propane. We wouldn't have something that exists like that. It wouldn't be called that. Instead, oh, I'm sure you hate me right now. This is, what is it? We've got a 4-carbon chain. It's butane with a methyl group hanging off the second carbon. So something that somebody could have tried calling 2-ethyl propane, well, I mean, they should have called it 2-methylbutane. So be careful, that sort of thing can happen. Your test wouldn't trick you like this. What it could do is ask, is the name of that 2-ethyl propane? And you'd have to say, no, it is not. It's 2-methylbutane, fools. Okay, draw 2,3-dimethylhexane. So hexane, 1, 2, 3, 4, 5, 6. Off the second carbon, I want a methyl group. Whoops. And then off the third carbon, I want, another methyl group. I'm going to put it down here just so it's a little bit more balanced. Now I have to make sure that all of my carbons have 4 bonds coming off of them. And if you want to be a perfectionist, you should draw all of your hydrogens on here. In fact, you should practice that because there's a good chance on your test that I will require you to write out all of the hydrogens. So don't be lazy like me. Write out all your hydrogens. Okay, there it is. That's 2,3-dimethylhexane. Now we're going to deal with heptene. Heptene, okay. 1, 2, 3, 4. put one over here. 5, 6, 7, but it's ene, so let's give it a double bond. And I want it to be 2-chloro, 3-methyl heptene. So I'm going to go ahead and group everything over here by the double bond so that everything's as early on in the chain as possible. So 2-chloral, 1, 2, chloro, 3-methyl. Okay, now make sure all my carbons have 4 lines coming off of them. This carbon has 1, 2, 3, 4. This carbon has 4. This carbon has 4. 3, 4, 4, 4, 4, and 4. And then chlorine, we know, tends to only form one bond, but since it has 7 valence electrons, and one of those got used, or sorry about that, it's got 7 valence electrons, and then it got 1 from carbon, which gave it a full 8. We need to show all of the electrons that go around it if we're going to be complete. A lot of times in organic chemistry, those get left off. However, if you get a question that asks you to draw all valence electrons, all free pairs of electrons, you would need to do that. So if the question doesn't ask you to, technically this is fine, but if it asks you to draw on those electrons, just draw them, put them on there. All right, finally we have 2,2,3-trichlorobutene, or butine. So but tells me I have a chain of 4 carbons. The ine ending tells me I have a triple bond. Well, I'll go ahead and put it on the other side this time, just for variety's sake. Then on the second carbon, I need a chloro. And then, on the second carbon again, I need another chloro. And on the third carbon, I need another chloro. 2, 2, 3, trichloro. There are 3 chloros. Now I need to make sure all my carbons have their 4 bonds, so I'll fill up the rest with hydrogens. If your carbon looks like it needs another bond, just throw a hydrogen on there. And then if I wanted to be completely accurate, I would give those chlorines those electrons, and I'd be done. So one last question before the end of this video. If I had been trying to name this guy, what if I had numbered it like this? What's wrong with numbering it that way? If I number it that way, then this whole prefix part up here is going to be 2, 3, 3 trichloro, and that'll be butine. And the problem with this, you don't want this is bad, don't do it. But the problem with it is you end up with more overall numbers. I guess if you add these up, 2 plus 3 plus 3 is greater than 2 plus 2 plus 3. So this is a better choice for your numbering system. All right, so there's your practice for simple groups. We're going to move into functional groups next time.